Hi! Okay, here we go. Let's do this division problem, ladies and gentlemen. And I'm going to teach it to you, hopefully, maybe not exactly like your 5th or 4th grade teacher taught you, but enough that I'm going to ask stuff you're like, we know Mr. Roberts, okay? Right? Does that make sense? 12 going into how much? What looks like a square root? Huh? 2137. All right. Erase that little, I get so used to just doing square roots, right? How many of you guys have never done long division? That there's always 1 to 2 kids per class, but the teacher either A had a baby, so they didn't learn it very well. That's pretty good. Oh, Heckelberger. Okay, so with this being the case, really what's the process here? We say to ourselves, self, how many times can 12 go into 2?
1.
I can't go into anything in 2, but then I move on, don't I? How many times can 12 go into 21? Once. What do we do with that number? We subtract what? Where did the 12 come from? I'm being serious. Let's go back all the way, because I'm trying to do this because this is what we're going to be doing today, but with polynomials. Okay? So what do? We take that number and multiply. Do you guys agree with me? Okay, that's 12. What do? Why? There's not a minus here. 1 times 12 isn't negative 12. The reason why is we're seeing how much is left over, right? But even though this was timesing, I negate it. Would you guys agree with that? This is 12. Then we subtract it, just like you said. 9, bring down the 3. I could even bring down the 7 if I wanted, right? How many times can 12 go into 93? And that's 84. By timesing, that's the key word. I went 7 times 12, right? Now you guys are like, we know, Mr. Roberts. I'm really serious. I'm just got to know the steps. What do we do then? Subtract what's left over, and then bring down the other one. 97, which is 8. 96 with 1. What do we call him? A remainder 1. Okay? But we don't like to say remainder 1. What's another way we could say this? This is step 178 plus a 12. Or you could say, as you just said, 178 and 12. Right? You guys all agree with that? Or we also learned that we could keep going with our decimals. Okay? Does everybody understand? We just take our remainder and put it over what we divided. Right? Does that all make sense? Yes, no?
Yeah.
Mr. Lincoln? Probably president. Okay. So, why? What's the process of this? Well, once again, we're going to jump into here. Okay? Here we go. Let's go x minus 2 going into x squared minus x minus 6. Let's do that. Nope. Plus x. Sorry about that. Okay. We're going to do long division. Just the same way. Okay? And I'm going to ask you the same questions. Now, really quickly before I start, I got a question for you guys. If I was going 37 into 292 with a 6 on the end, let's say that, 2,926. What is your thought process in this? Because how many of you guys know your 37 times table? With 12, it was pretty easy because we know our 12 times table. No. But with 37, I don't know that very well. So I don't know what 37 times 5 is, or 37 times 3 all the time quickly. Do you guys agree? So what did you guys do to kind of get an idea of what it was? Just a guess and check, or what did you guys do? I had a way I did. I'm just curious what you guys did. The how, though. How did you figure out what number to use without using a calculator? What did you do, Wyatt?
What I usually do is like say it's divided by 40 since I do know how to multiply forwards, and then just
or 30, right?
Yeah, I'm just picking code number.
So exactly, that's kind of what I'm trying to talk about. Is we kind of round up or round down a lot of times, don't we? This is kind of like more like 30 or more like 40, and then I kind of say, oh, how many times can 40 go into 292? It's a little bit closer to try, right? Does everybody, you guys remember doing something of that case? Did you do that, Hallie? At one time? No? What did you do? I'm just curious. Used your machine? You were a machine user. Oh, you're one of those. Your teacher just ruined you for the rest of your life. Yeah, machine user. Love you anyway. Okay, but once again, I don't think I had a calculator until I hit 8th grade. I wasn't allowed to use it. And because we did that, but once again, it's a rounding. And notice I kind of ignored that 7. I kind of went to either the 30 or I rounded up to 40. Same thing here. I'm going to ignore this -2 as a red-headed stepchild. Your stepchild, bet you. Okay, good. Nope. Okay. I've had a redhead every class grade. It's kind of fun. Anyway, with that being said, I kind of just ignore that -2 and I'm just going to look at x. Okay? And I say to myself, how does x become x squared? I times it by x, correct? And that's the whole goal, is I'm going to times it by x. Now, once again, we're going to treat this like 4th grade learning division. What did we do at this step? We took this number and did what to it? Multiplied it to him, did I not first? I went this times this. Well, what is x times x minus 2? You with me? If not, you got to talk to me because it's very important to make sure you guys know the steps that we're doing. Okay. What did you get? It doesn't matter. It really doesn't. I like to place them above whatever they're supposed to be. This is our linear term, something above. Could I put him all the way the heck over here? Okay. So, what do we do at that stage? We subtracted that 12. Remember, 1 times 12 wasn't -12, it was 12. So what did we do? We subtracted, didn't we? When we subtract a binomial, am I not subtracting this? Like that, right? When I do that, is that not the same thing as just distributing the negative through? Which does what? Switches my signs, doesn't it? Right? Switches my sign. So basically, I'm going to undo those things just so you guys can see what I typically do normally. I usually say, I need to subtract this. And when I subtract a polynomial, all that is switching my sign. Does everybody understand why I'm switching my signs, though? Not just because, it's because I'm subtracting that polynomial. Notice, once again, when I subtract it, I just distribute that negative through, which does what? Switches my sign. Everybody with me on why I'm doing that? Key goal, when I was taught, they're like, just subtract it. But they didn't even say subtract it, they're like, switch the signs. I'm like, why the heck am I switching my sign? I had no idea. And I'm like, I'm subtracting! That's why. I had to connect it. There's so much in my math life that I wish that our teachers would just go a little deeper on. Not just because they told you to, it's because of here's the reasoning, and you would understand a little bit deeper. You understand the process. I was just always told, switch the signs. But why are we switching the signs? Because I'm subtracting the polynomial, and when I subtract the polynomial, it's distributing that negative through, which is doing what? Switching the sign. With me? What's left over? This is gone. This becomes 3x minus 6. Okay, so now I say, okay, well, how does x become 3x? I need to times by 3, don't I? Are you there with me? Okay. 3 times x minus 2. 3x minus 6. But what do I need to do to that? I need to subtract it, which means what? Switching our signs. And what do we get? Meaning there's no remainder. So that means it's a perfect factor. What's a perfect factor of 24? 6, 8, 3, something that goes in perfectly. Is 5 a perfect factor of 24? No, I have some remainders, right? So remember, if it's a perfect factor remainder 0, that means this times this should give me this, huh? Does x plus 3 times x minus 2 give me x squared plus x minus 6? It would, wouldn't it? Okay. So what am I doing? I'm just dividing the same way I did long division with numbers, but I'm doing it here. Now, some people get confused. Mr. Roberts, why did I put a plus 3 and not just put a 3 up there like I would on the other one? Well, I'll go back to this problem here, and bear with me. I'm going to do it all over again. Okay? 12 goes into what number did I have there again? 21? 37. No, I did, but you were just really fast. I'll shut up. So we went into what? What do we say here? 1. Isn't that technically I'm going into this 100 times? Because that's why I put it above it. And then that's like 1,200. And then what's left over? 937. Then I said, how many times can 12 go into 930? 70 times. Am I really not doing that? Isn't that truly what's happening, even though I'm not doing that? That would be, oh, that's this, correct? How many times can 12 go into 97? Hence 178. That's really what we're doing. So hence why I have the plus in between just as well. Right? Does everybody understand why that's the case? Okay. You see how it's so correlated to what we did on long division, hence why we started with the very basic. Let's remember how to do this so that we can do that now with polynomials. Okay? All right. Are we doing okay? How are we feeling? All right. I like you because you talk to me. Chuck. Chuck, do you have your license?
I do have my license.
Oh, Chuck. Chuck, why you gotta be so nice? That's what your mama raised you to be, huh? Chuck, do you got a lady to be taken to the old homecoming?
No, I do not.
Chuck! What the heck, Chuck? What up, Chuck?
How you doing?
Chuck, why are we not going to homecoming? This is being recorded.
I don't know.
You have 1 week and 2 days. Extra credit, remember, when that A is not what you want, an A minus. I'll be all like, you go to homecoming? You're like, no, I'm going to Robert. I'll be like, get that A minus, get that A minus. Chuck, look at all these lovely ladies. Right here, boom. Right back there. Are you invited already? Oh, damn, can't go with her. Going back where Tay got it. We're not getting on the spot, but you get the idea. I did too. Sorry, that's all. Last time I said I didn't know, but I hope it goes. But keep it. But that was awesome. My awkward meter is awesome. All right. And you don't have. Sometimes I think we have to go all the way extreme. You know, just make her a lovely girl too. Okay. She'll be excited she's going. Nowadays, remember, back in my day, pictures were $50 a couple. Nowadays, you just have your great grandma do it. Right? That's out the window. We got grilled cheese, pictures taken. You go to church, Chuck.
I do not attend church.
That's okay, Chuck. You got a tie, Chuck?
I do have a tie.
You got a shirt that goes with the tie, Chuck?
I do have a shirt.
What up, Chuck? You can go. See where I'm getting at this, Chuck? The biggest cost would be what? I could get you a rose out of my backyard. We'll just flap it on her. Okay? Just telling you. We got this hooked up. You need it, Chuck? You tell. $40 for the 35 because we're going to free pie. All right. There we go. Isaac, I need to come after you. Are you asked yet? Oh my goodness. Are you going to tell me you're not 16? Okay. which is fine. Okay, what was the first thing I had? 8, hopefully that didn't work. 8x to the fourth, right? Then what was next? Ooh, we're missing something. What are we missing? We're missing the cubic term, aren't we? And we need a placeholder for that cubic term. So is 0x cubed the same thing? I didn't change the value of it. I just put it as a placeholder. Does that make sense? Okay, what's after that? You said 6x squared. Am I correct in that? After that? And after that? What are we dividing by? First off, can 2x squared minus x plus 2 be factored? Factors of 4 that add to be 1. Can't do anything, can I? Okay, so sometimes you just want to see if those guys can be broken down, because I'll show you an easier way in a minute. Okay. All right, here we go. How does 2x squared become 8x to the fourth? How does 2 become 8? Go there. Times by 4. How does x squared become x to the fourth? Times by x squared. Does everybody see how I'm getting that thinking and reasoning process of what number goes on top? Okay, 4x squared times 2x squared is 8x to the fourth. 4x squared times a negative x. If I didn't have that placeholder, now we're in a little hard time, huh? That'd be negative 4x cubed, and I wouldn't have that placeholder where I need somebody there. Does that make sense? Does that make sense why I put a placeholder? Okay. 4x squared times 2. I see you hanging out with the ladies outside. Was there not like 3 ladies in your circle?
There was 2, but that's close enough. That's a major one.
Have they been asked about?
No, one of them hasn't.
Yeah, I'm reeling you in, buddy. I'll go buy the Swedish fish tonight. Throw it at her tomorrow and say, of all the fish in the sea, you can go with me. Yeah? No? Why, yeah? All right. See, I'm telling you, I got you. Shut up. Now, what do I need to do here? I'm just having a fun time. Your guys' class is probably going to get the worst lesson every time, and I apologize. Well, that's on you. I showed the damn example. And that's important. What do you, I'll be honest, do I remember, except for my teacher dressing up in a weasel suit? No. Yes, sir.
Where do you find these?
Yes, on the website. You know where the website is?
No.
Go to my Westlake website. You know where the Westlake website is?
Yeah.
Then go to faculty and find me and click on my website.
Yeah.
What up, Chuck? That was rude. Adam. Here we go. How does 2x squared become 4x cubed? By 2x. There we go. Somebody said it. 2x times 2x squared is 4x cubed minus 2x squared plus 4x. Is everybody there with me? What do? Why do we change the signs? So I'm not just changing the signs. Why am I doing so? Because I am subtracting this polynomial, right? That's the reasoning. Gone. Gone. We're left with what? Negative 7x? Is that correct? Plus 1. Rafe, how about you, brother? I'm 0 for 3 today? Have you asked, Rafe? Okay, Rafe. You're not like Chuck. I saw him hanging out with the ladies. I don't know if I've seen him out there. I'll shut up again. Okay. Can I go 2x squared into 7x? Why? Not necessarily 2. I can make it 2 go into 7. How do I make it 2 go into 7? Times by negative 7 halves. Oh, I would. But I'm not going to. It's not because it's the 7 halves. It's because how many times can x squared go into x? I can't make an x squared go into x. Yeah. Does that make sense? I'm done, ladies and gentlemen. But this time I have a what? Remainder. So how do I write that? It was 4x squared, right? Was that what it was? 4x squared? 4x squared plus 2x. It was negative 7x plus 1. Over what were we dividing by? 2x squared, I know, plus 2, right? That would be the answer. So was that a factor of that other polynomial? Was it perfectly divided in?
No.
How do you guys feel? Not hard, right? What's the key thing you got to do there? What's the biggest thing I've seen people mess up in the past? A, not keeping a placeholder. Got to have that placeholder. 2 is negating and distributing that negative through. But distribute to the first guy, but don't forget to go into the next one. Does that make sense? Remember to get it in. I'll find you tomorrow, Chuck. No, Chuck doesn't need a dot. How is Chuck messed up? Touche. Chuck, Callie wants to give you a dot. She said she messed up twice. Not just once. Hence you got a dot of shame. All right, ladies and gentlemen. We're going to go back to the first example we did, but we're going to do it a different way. This is called synthetic division. Okay? Synthetic, S-Y-N-T-H-E-T. Yeah, I see. I'm not a speller. That's why we have spell check nowadays, right?
Yeah.
You get it semi-close, I'm going to do it for you. Shut your mouth. Eichelberger, you really did a dog shame. Unless I leave now, we'll walk back there. Okay, so synthetic division, notice we did 2 problems. We did one that was a linear binomial that we were dividing by. That was our very first problem, correct? On the second problem, we divided by a quadratic equation that was a trinomial, did we not? But on a synthetic, you can only use linear binomial. Write that down. You can only use synthetic when your divisor is a linear binomial. You can only use synthetic when your divisor is a linear binomial. So which problem could I do it on? 1 or 2, the ones I've already showed. Problem number 1. Okay? Synthetic is going to become your best friend. When we get into our next unit, after the first step, we use synthetic a lot. It is something that I would use over long division, not saying that I can't use long division. Long division is great, we just saw how we could do it, but it is tedious and long. Okay? There's a simpler way that we could go through this process, and that is by doing synthetic. What did we have again? First I had x squared minus x, was it minus or plus? Minus 6, right? And x divided by, like that? Is that what it was? I don't think that's what I had. I think I had a plus here.
No, x squared plus x.
I think I changed it to a plus. Okay, that makes sense. All right, here we go. At first, you're going to look at me, what the heck are you doing, Mr. Roberts? Okay, I'm going to show you the procedure, and then we're going to talk about it, okay? Everybody there with me? Understand you might not see, you might get the math really quick, but you might not understand why really quick. I'll explain that as we do a couple times. Good deal? This one you're just going to trust me a little bit. You have trust faith in me? That hurts. You're cold. Okay, tell me the coefficients of my quadratic. 1, 1, negative 6. Everybody there with me? Those are the coefficients. Now, go ahead, get the coefficients, and then bring it down and over. You might say, why am I bringing it down and over? Just do it for me right now, and then I'll explain. I'm not making you do this blind. I will explain, but right now, it's easier after I start the problem and actually do it, and I can talk to you about it. Okay? By the way, what was our result of this when I actually did x squared plus x minus 6 divided by x minus 2? We got x plus 3, did we not?
Yeah.
Let's see if we can get the same. What value makes this guy 0? 2. Does everybody agree 2? Okay. Put him here. That is what we're dividing by. Okay? Here we go. This line's here because just bring down this coefficient. He's a 1. Now, remember, when we did other division, we subtracted, didn't we? But because I found the opposite of what was up here, x minus 2, what's the opposite of seeing negative 2? Positive 2, hence it's a 2, right? Is everybody with me on that? I don't have to subtract it anymore. I just get to add the rows. Here's what you do, though. You go 2 times 1, which is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. Now, you might be like, that's just a lot of numbers. Okay? Those numbers have meaning. What is this meaning? X squared plus x minus 6, correct? What is this meaning? This means x plus 3. That is our answer. Now, you might like, where the heck did that guy just come from? Right? And it's technically already in your division problem. If you look at your example 1, let's look at it. Okay, how did x become x squared? 1. I times it by 1 and I got x squared minus 2x. Notice this is our x column, and it was minus 2x, wasn't it? But then what did I have to do? I subtracted it, which flipped him into a positive. What was 1 plus 2? 3, and then he kind of came along. And I said, okay, how can x go into x? Or excuse me, how could x go into 3? Right here. So notice, those things always canceled out, right? Every time I divided, didn't the first term always cancel out? And we were really just dealing with what was the next term. So we went 2 times 3, which is 6. Okay, and that means its remainder 0. So let me ask you this question. Why did I go from x squared down to x? The reason being is, remember, what is this guy representing? A linear binomial, right? Let me ask you this. If I had, over on this board, x to the 4th, blah, 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 I don't care, divided by, let's make it a 2x to the 4th, and I have x plus 1. How does x become 2x to the 4th? 2x cubed. Notice, the coefficient stayed the same, didn't it? That's why you just bring down the coefficient. Okay? Why did it come from x to the 4th to x to the 3rd? What am I dividing by? A linear binomial. Isn't that taking it down by 1 degree? How many times can x go into x to the 4th? Shouldn't that be less 1 than what it is? If I had x to the 7th, doesn't it take x to the 6th times x to get me to x to the 7th? Doesn't it always just take me 1 less degree than what it was? You guys get what I'm saying by that? So notice, this was x squared. So what does this represent? The linear term x. Okay? So right now, you might be all looking at me a little weird, but let's try it one more time. Let's do another one. All right, let's try this guy right here. Where's he at? Okay. So what's my coefficients of the leading, or of the top equation? 1, -8, 2. That's a quadratic? Is it a quadratic? That's a cubic up there, but this is saying it's a quadratic. And let me explain. That's my constant. That's my linear term. That's my quadratic term. What am I missing? There's no x squared up there, but I'm missing a placeholder. I need a 0 there, don't I? Because I have a constant, a linear, no quadratics, and 1 cubic. You do need to put your placeholders, right? Any questions by that? Okay. So here we go. X plus 3. What's the value that makes him 0? Okay. Once again, why do I get to bring down a 1? Let me explain. How can x get into x cubed? By 1x squared, and hence he was x cubed. What's he going to be? This whole thing's going to be x squared, because we're going down 1 degree. Does everybody understand why you go down 1 degree? That's a very big, important part. You shook your head no, right? Am I correct? Okay. Do you understand that if I had this, how many times can x go into x cubed? Not 2 times. Not 3 times. X times what? X times 2 would give me 2x. That's not what I'm looking for. I need an x squared. Right? But notice, this number is representing x, because remember, it's coming from a linear binomial. That was one of our restrictions on synthetic. It had to be a linear binomial, correct? So every single time, here, and I want to say, here, Caitlin, that's close, sorry. How does x come into any term? It's going to be exactly what he is, but just 1 less than him. Hence why, if he's x cubed, he'll be x squared. If he was x to the 8th, what would he be? Exactly. Everybody with me on that? Yes? Okay, and I keep going. What do I do to these numbers? Times them, just like I would in division. Then what do I do to these numbers? I don't subtract. Why don't I subtract? Because I've already done it, because I've switched the sign here, haven't I? 0 minus 3 is -3. -3 times -3 is 9. -8 plus 9, 1. -3 times 1, -3. And I left with a -1. So what's my result? Did it go into it nicely? Last time, if you'll recall, I had a 0 on the end. That meant it went into it perfectly, didn't it? Because I had no remainder. This time, did it go in nicely? No. Is it a factor? No, but is it still, can I divide something that's not perfect, just like can I put 5 into 24? Just not nice, right? You guys agree with me? Kind of get what I'm going at? So what does this represent? Once again, what does this 1 represent? X squared minus 3x plus 1. What does this represent? The remainder. That would be my answer. It's just a quicker method than long division. So you try to kind of analyze it to see why it's exactly the same thing. And the main reason is because you're flipping the sign, right? You're going down 1 degree because it's always a linear. Okay, you're dividing by a linear. That's the reason why you go down by 1 degree. Okay, those are the 2 big ideas. Should I let you guys try one? Okay, here we go. Let's have you try. I didn't mean to keep using 2 and nice numbers, but it is what it is sometimes. Okay, so what's our first goal? Write the what? The coefficient. Do we have any missing coefficients? So we're good to just go down the line, right? But you always want to check, do I have everything that I need? Right? Okay, here we go. What did we get?
1, 1, 1,
Yes, we okay? Who are we going to be dividing by? Because it's what makes this guy 0. Okay, go from there. See what you got. What goes here? 1. You just bring right down the coefficient, hence why I have that little bar there, okay? What do we do to these numbers? Times them. I see some people looking in their notes. Does everybody understand why I'm timesing these guys? Just like I would. 2 times 1 is? That's why I'm getting these missing marks. -1 plus 2. What do we do to those? Times them again, right? Two times 3 is? Well. So, what is the answer? Once again, this was x to the 4th. What's this guy? X cubed. How did I get 10? What were we dividing by x minus 2, right? There it is. Okay? Very simple concept. I have a question for you, though. Let's call him f of x up here. Let's actually go on to the other side really quick. If somebody remember, tell me what that says. So if I said f of x was x to the 4th minus x cubed plus x squared. Okay. If I wanted you guys to find f of 2, what would you guys do? You put 2 in for x. And this was 2 to the 4th minus 2 cubed plus 2 squared minus 2 plus 2. Oh, that's a lot of work. And then I got to think, what's 2 to the 4th? That's 16 minus 8 plus 4 minus 2 plus 2. Holy crikey, it's 12. I already knew that f2 was 12. It's right there. So, anytime, guys, that you do synthetic division, it's also a point on your graph. So f of 2, as I saw right here, was 12. How many of you guys really want to put 3 in here and do 3 to the 4th? That's when you start having a hard time. Or if I wanted to do 6 in there. How many of you guys know what 6 to the 4th is without using your calculator? It starts getting a little problematic, doesn't it? Let me show you how fast it is if I wanted you guys to find f to the 6th. Okay, if I want to find f to the of 6, once again, using those coefficients, I have 1, -1, 1, -1, 2. Am I correct? Isn't that the number?
Yeah.
So f of 6, what would he be? This is called the remainder theorem. I plug a 6 in here. 1, 6, 5, 30,
31, it's getting big, but I can handle it still. $185, that's 30. There he is. It's a little bit quicker than thinking about what is 6 to the 4th minus 6 2. You know what I mean? This allows you to find any value as well. Synthetic division can allow us to find it. It's called the remainder theorem. If you come up with a remainder, that's the value of what it would have been if I plugged it in. Now, after we test, we're going to need something else. We're going to look for, remember that one that we said it couldn't factor, where we were looking for the zeros? You guys remember that one that we had that was the x cubed that couldn't factor? Okay, we'll be using synthetic. And what do we want it to equal on the end? A 0, because that's when it hits the x-axis, or when it's 0. Okay, so synthetic's going to be our friend coming up. But what you can do is it goes in perfectly. Sometimes they ask is, okay, for example, what did I divide by? X minus 2? Is that what I divided by on the last problem? So was x minus 2 a factor? No, why? Because it didn't equal 0. Didn't go into it nicely, did it? Is everybody there with me and understanding on what I mean by that? Anybody see 1-6 anywhere? I lose these. Really, I don't. But walking around. Nobody has them? Okay, you're going to be doing odds tonight.